Here we are given a pair of overlapping similar triangles, which means that the triangles have the exact same shape but are different sizes. We can use this knowledge to set up proportions in order to solve for unknown sizes. Before you start on a problem like this, especially with overlapping triangles, it's important to draw and label your two triangles separately. Now that I've drawn the two triangles separately, it's important that I label the side lengths. On my larger triangle, SQP, I've got one side length of 12, I've got another side length of 12, which I get by adding 9 and 3 together. And for the side length PS, I notice that I have two pieces. I've got one piece that's 15 and one piece that is X. I need to put those together through addition, so this will be 15 plus X. Now looking at my smaller triangle, I've got one side of Y, one side of 3, and one side of X. Now I'm able to set up a proportion to solve. What's important with the proportion I set up is to ensure that I do not have more than one variable at a given time. So I would not want to have to try and find Y and X at the same time. So what I'm noticing is I can use side QS and side RS, and I can use side PS and TS to find my variable X. So if I go from the larger triangle to the small triangle, I can compare 12 to 3, QS to RS, as PS is to TS. Once I have my proportion set up, I can use the cross product property to solve. So I will multiply the things that are diagonal from each other and set them equal to each other. Notice here I'm going to need to distribute. So simplifying algebraically, I'll get 12x is equal to 45 plus 3x. Now I can subtract 3x from both sides of the equation, which will give me 9x is equal to 45. And finally, dividing both sides by 9 gives me x is equal to 5. Now, checking my work, I notice that if I substitute back in, I would get a length of 20 here and 5 here. And seeing as the first leg I used, I went from 12 to 3, which is a zoom factor of 1/4. I notice now that going from 20 to 5 would also be a zoom factor of 1/4. That's a great way to check my work. I still need to find Y, but now I have options as to what sides I use. I know that 12 and Y are corresponding, and so I can choose to either use 20 and 5 or 12 and 3 for my other set. So I can do 12 is to Y as 20 is to 5. Using the cross product property, I will get 20y is equal to 60. And dividing both sides by 20, I'll get y is equal to 3. Which hopefully you predicted, because you may have noticed that this was an isosceles triangle. So we would hope that this would be an isosceles triangle as well, which is what we have found.